Hello, this is Vijayakumar, Assistant Professor, Department of Physics, SNS College of Engineering. Today I am taking the topic of based on design thinking, that means DT concept, the case study on semiconducting material and its applications. So the first we discussed from this case study is the introduction of semiconducting material. The semiconducting material in between of conductor and non-conductor or insulator, it's called a semiconducting material. It's normally to form of small band gap from the insulator. The pure element is a silicon or germanium, that is an example of semiconductor. The compound element is a gallium arsenide or cadmium sulfate. So the band gap means the distance between the conduction band and valence band to based on the energy of the charge transfer. The next one, we discussed the resistivity based on the material. So the different material I mentioned from this graph to based on the resistivity and conductivity. The resistivity will be increased and the conductivity become decreased manner. So the material become classified in based on the resistivity and conductivity of three categories. One is a conductor, semiconductor and insulator. So the semiconductor category is the middle of these two of resistivity and conductivity. So the next one is the properties wise we have discussed to the form of element and compound semiconductor. The element is a single mode and compound is a multi-mode of material to be added. It's a create of compound semiconductor. From in our periodic table, the fourth group and the sixth group element is called as a elemental semiconductor, but compound semiconductor is a third and fifth or second. This all is a compound. So the element semiconductor we say is an indirect band gap semiconductor. Then opponent of compound is a direct band gap. Then heat produced in the recombinations, but here the photons and emit during the recombinations. The lifetime charge carrier is more due to indirect recombination. The lifetime of charge carrier is less due to indirect. So this all is a property to the form of element and compound. Then the comparison between n type and p type is a pentavalent, that we call as a n type, and trivalent is called as a p type. The majority carrier is electron and minority carrier is holes. Here become is the opponent of. The next very important is Fermi level, we discussed from here in conduction band, but there is closer from in a valency band. So then next we discuss the concept of DT, the design thinking concept. So the 5 steps is in a concept of DT. The empathy, define, ideate, prototype and testing. So this has become create a solution of my topic. The first one, empathy. So the increasing of conductivity and temperature dependent addition of impurities, change of bandwidth. This all I am taken from the empathy of this topic of semiconductor case study. Then second one, addition of impurities, that we form in our second category of define in DT. So when we add impurity or semiconductor, we call them dopant and the process is called doping. So the extrinsic semiconductor is a form of this. The next one, it's a form of other type in extrinsics, that means n type and p type, that means penta and trivalent. Then the ideate, we start from the different category of semiconducting materials. So the thin film is a 28%, then crystalline solid we have used in 70%. So the ideate process to the form of semiconducting material, certain percentage level we have classified. Then phototype we have used in the semiconducting material in a solar cell panels. The solar cell panels is a form of two types. One is in a mono and another one is in a poly type. This both will be form of the material is silica. The silica is an element of the semiconducting material, one of the best example. So the solar cell is a fabricated of the semiconducting material. Then this all is in a testing process to applying to connected of solar panels in a electrical devices. So the function of this N type and P type, then P type material. So the photoelectric effect based on this act in the solar panel, finally we have get some electrical charges. Then the another one types we discussed, that is a normal solar cell. The next one is in a hybrid solar cell. This all is a testing concept of the DT. So the different category wise I have given the picture to the form of hybrids formation. That means the vertical manner and horizontal manner and different layers formation, this all to be formed in hybrid. Then future of the solar cell. The solar energy, we know that we need to create of electricity to the form of photovoltaics. Then developing solar industries and providing market condition and public policies. Then generated grid contact solar power generator. The small scale PV generation is outweighed very high value of access to electricity for lighting and charging mobile, telephone and radio batteries. This all is act of future of this case study to under the DT concept. So this all the reference I prepare from this case study of semiconducting material to applying of DT. Thank you very much. We meet the next topic from the next one class. Thank you.